Alright guys, today we are going to solve LeetCode number 1 2-sum, and the problem statement is to find two numbers that add up to a target. In our case it's 9, and also we have to return the indexes and not numbers. And in our case, our two numbers that add up to the target, which is 9, are number 2 and number 7 with index 0 and 1. That's what we return. So let's solve these problems, and let me go through the naive approach. So naive approach is to take a number, let's say starting from 0th index, and this one, and what we are gonna do is we are gonna compare with each element and find if they sum up to the target. So here we can see the index 0 and 7, they add up to the target 9. This would work, but the question is that the time complexity to run this solution is big of n square. They want you to do it in less than big of n square. So let's go through the another approach, which is to sort the list as it was not sorted earlier, and then we can run two pointers on it. So two pointer basically means let's take the leftmost index and the rightmost index, which is if we are taking 0 1 2 3, so our one pointer is pointing at here and the other point is pointing at here. Since they are sorted, the last number would be always bigger and then the first number will be always less. Now add these two numbers. Now 15 plus 2 equals to 17, which is greater than 9. So if that happens, if it's greater than 9, we are gonna reduce the end and we are moving to, so now the right pointer is at second index and the left pointer is still at 0th index. We compare again. Now the sum of these two is 2 plus 11, which is 13, and which is still greater than 9. Now we decrease the right pointer and which points here, and this is first indexed, and we sum now. The sum is 2 plus 7, that would be 9, and this is the answer we wanted. So this works, which is faster than before, and when we check the time complexity of this thing, it's gonna be n log n, because if you sort a list, that's the best time we can do from the known sorting algorithms. So the third approach is to use hash map and save the difference between target and the number at index, and check if it's present in the hash map, then the sum adds up to target, and if not, then we are going to add the difference between the target and the number at the index to hash map for future use. So first what we check is if 2 is present in the hash map. It says no, hash map is empty. So we are going to find difference between target and the number at the index, which is 7, and we are going to put 7 at 0th index. We do the same thing with second. We are at here. Now do we have 5 in the hash map? No. So what are we going to do is 9 minus 5 equals to 4. 4 we add here and index up 1. We go to third index, which is 8, and we check if 8 is in the hash map. No. Then we do 9 minus 8 equals to 1, and 1 is at the second index. So these are the index. Now we are at the third index, and the value at the third index is 11. We check if 11 is in the hash map. It says no, and then what we do is we subtract 11 from 9, which is minus 2, and minus 2 equals to third. Now we come at 7 and we check is 7 in the hash map, and we say yes. So what we are going to return is, since this was at the fourth index, which was at the fourth index, and this one is at the 0th index, so what we are going to do is return the current index and hash map of 7. Now let's go ahead and code it. First of all, we need a hash map to store the remainder and index. We loop through the range of length of nums, and we calculate the remainder. That would be target minus the nums index, that would be the number. And we check if that remainder is in the hash map, and if it's in the hash map, we just return the index and the index that was saved in the hash map of remainder, and if not, then we'll go ahead and add the number into the hash map with the value of index. And let's run it. Yeah, it's pretty fast. We sacrificed the memory, but yeah, this works. Thank you so much.